So in the previous video, we have been looking at functions that are built in into Python, and here we are going to be looking at user-defined function. So far, we have only been seeing functions that come with Python, and it's possible to add new functions. That is what you actually want the program to do. You can group those statements together and give them a name in a function. So a function definition specifies the name of a new function and the sequence of statements that run when the function is called. So here's an example. I have the def keyword, which is used in defining a function, and I also have the name of the function followed by parentheses. The same rule applied to variable name in Python is applicable to functions name here, and I cannot use keyword such as print alone without this lyrics. I cannot use it to name my function because there's already an inbuilt function name that is named print, and it is being reserved for Python consumption only. So I cannot use print alone to name my function. This will return an error. So yeah, I have the def keyword, which is used in defining the function, and I also have the name of the function and followed by parentheses, which means this is a function. Then in Python, indentation is very important. So here I have my colon here to say okay, after the keyword to define a function, then the function name, then this colon will be used to say okay, I still have some statement that will come after this function, which are what I have here. In most programming language, instead of using colon as a as an as something that you use in identifying that this particular line has some nested chart, in other program language we use the curly brackets to define those. So now in this function, there are some series of statements to be executed. The first line here in this function says that it should print I am a lumberjack and I'm okay. This is a string that is being passed into the print function for it to execute whatever it is being inputted here and output it to the screen. And also another function, another string that says I sleep all night and I work all day. So yeah, I can just copy this function here. I copy it and I go into my code here. I go into my interpreter and I say okay, I have I go into my code, I create a new file. Then inside that new file I just say a function .py. Then inside this file I have the function that was copied earlier, and as you can see, Python highlights this line to be an error. It said expected indentation block, expected indentation block. So yeah, I have to indent this line to ensure that okay, whatever I'm going to be having are nested inside this definition, this function definition. Then this function is only defining something. If I should save my program, I'll try to run it here by saying Python, then the name of the program, which is a function, then it should return nothing because I'm not actually doing something. This print function are not actually doing anything because they are nested inside a function name print lyrics. But if I want this function to actually work, then I have to call this function by calling the function name and followed by the parentheses. If I should say okay, print lyrics, this is just like I'm displaying the name of the function, but using this parenthesis I'm trying to call this function so that every code that I have in within this indentation will be executed. So I save my file and I come down here to run the file again. Here it's now outputting something to the string. It says I am a lumberjack, and so whatever input that I've put in my print statement here do not actually compute only until I call the function using the function name followed by this parenthesis. And these are just an example of what function can actually do for us. Okay, so after we are now familiar with some of the user defined function, let's go back to our maths.py file that I created earlier. Here on the first line I try to import the math module, which is also a script in Python, but it is built in into Python. I'll import the math module. I want to work with this math module, but I need something to work with. What I want to do here is write a function that calculates the circumference of a circle. Here I can just write a function by giving the keyword def. I'm trying to define a function, then I call it circumference, circum, then I open this parenthesis. This parenthesis, if I'm trying to check for the circumference of a circle, then I can just say, okay, the circumference of a circle says for you to use this, then you have to do something that we call 2 pi r, which means 2 multiplied by whatever we have as our pi value, which is pi, then multiplied by r. This is the formula for checking for the circumference of a circle, to pi r circumference of a circle. So here, if I want to do this, actually I can just come down here and say, okay, let's go inside this function, then followed by this colon. I can just say, okay, I want to get the circumference of a circle with radius, because I know that this 2 is a constant. This pi, I can get it from this math module. Then the radius have to be provided, because I'm trying to get a value from this function by giving it a radius and say, okay, compute for this radius. If I give you this radius, then find the circumference of the circle using this radius. So what I can do in this case is just to come inside the function and say, okay, I should have a print statement that will print something out to the screen. What is it going to print out to the screen? It's going to print out 2 then multiplied by pi. I need my pi here, so I can just say, okay, the pi is going to be in a variable called pi. Then this pi, I can just say it is equal to math. I want to consume a function in math object, in math module. I can say math.pi. Then this will get the pi variable in the math module and store it in my own local variable here, pi. So I can just call the pi variable here, instead of me having to type the pi value 3.14 after every time that I need it. I can save it in the variable name pi. So here I am having 2 multiplied by pi, then also multiplied by r. Here I don't have my value r, and I need an integer value or any value that I can use then to get the circumference of such circle. So here I can just have my r to be, let's say the radius is 7. Then I can come down here and say, okay, 2 multiplied by pi dot multiplied by r. Then this will return the circumference of a circle with radius 7. Here I'm using the 2 variable names. This is an expression that is being passed into a function. So 2 multiplied by pi, then multiplied by the radius, which is 7. So to save my file, I come down here to run the program, which I called maths, .py. Then I run the program. Nothing is being outputted to the screen. Yes, that is because I'm just defining this function and I'm not calling this function. So for me to call this function, I have to come down here and say, okay, to call this function, I call the function by its name by saying circum, then followed by the parenthesis, saving my file, and I come down here again to output whatever I have. Then it is returning the circumference of a circle with the radius 7. So if I call this again, it will still return that same value, but I can get a dynamic response by saying, okay, I have to change the value here now. Let's say I want for the radius 6. I save my file, I come down here again to run my program again. Then now we can see that we have different value here. So to get different value without having to come into our function, but for that function to have its own value whenever you are calling it and to work with those value, we call those things argument and parameters. So now let's go back into our notes to see what we mean by argument and parameters. So here we have a function definition and all that. We can go down to see what we mean by header. The first line of the function definition is called the header, and the rest of is called the body, which means if I have a function such as this, then this first line is called the header and the other subsequent line are called the body of the function. which is whatever the function is trying to do to. So all quotation mark single quote must. So as I was saying earlier, if you have a function and you are working with a function, the function definition in interactive mode, the interpreter prints dot 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 to let you know that the function isn't complete, like we have here. So I have my definition here, which is the header. Then I have the body of the function here, which was indented by this. And like I said earlier, I said this colon is used to tell the interpreter that okay, go inside this line and run the program that is nested inside this line. So yeah, I'm having my variable names and what I want the function to actually do. While indenting, I'm giving it some space. But in our interpreter, what we will get when we are trying to define a function is that if I have define, then I want to define a function called let's say print ln. Then I just open and close parentheses, then I use the colon. As you can see, we have these three dots, but that is not what I actually have to work with. I have to put in another indentation. This three dots is just notifying that I'm not done with this function definition, because there are some things that have to be done also again. Then I can now put in any code that I want to work with. But if I'm confused or I mistaken this three dot as an indentation, then this Python will return an error. Let's say I now say okay, this should print something to the screen. What I want it to print to the screen is just to say I in the function. So it return an error. It says this indentation error, which means this three dots is just telling you that what you have to do in this case is that the print these three dots is used to let you know that the definition isn't complete. So you have to be very careful while using it, because I can just have my function definition again, function definition, and say okay, I want you to do something, print ln, then open and close parentheses, then this colon, then this, I now have to put my indentation by saying okay, what this function will now actually do for me now is to print something onto the screen by saying I to the cursor. I press enter but nothing happened, which means it is still indenting something for me here, but I am done with the function. What can I do to terminate this? I press enter again, then it returned my prompt here for me. Now I can now call my function by calling the function name using print ln, then followed by parentheses. This will print ln followed by parentheses. This will return the output of this function, which is to print I, which is what is returned to this screen. But what if I just say okay, print ln without the parentheses? What will be the output? It's just trying to say okay, what I'm trying to do here is function print ln is saved at this location of my program. So print ln is just like a name, then using this parenthesis after the function name is saying okay, I'm now trying to invoke the function. So now let's go back into our notes. By here we can look at what we have here. It says to end the function you have to enter an empty line. That is if you are working with the Python interpreter directly. So to end the function you have to enter another empty line, then the prompt will return to another point. So defining a function creates function object which has type function. Like I did earlier, I only call the function name, which is print ln, then it return the function object and it's return that location where it is. So if I want to check for the type of that function, I only have to enter the function name, which is going to return that okay, whatever you're trying to check for the type is a function. But to call a function, you use the parentheses, which will now force it to return or to print out any value that is being imputed into the function after the indentation. So that is about function in Python, the simple function we can find in Python programming. In the next video, we'll be looking at functions that take in parameters.